Okay, guys. Well, okay. This is version 2 because okay. We have two streaming video subscription services that offer family plans with different monthly costs. Showing the ads, what do they have in common? How are they different? When is this one better? When is Movies for You a better deal than Family Stream? So I'm going to kind of just split it up here. I'm going to have Movies for You over here. I'm going to do this in gold, and I'll do Family Stream, I guess, in purple. Maybe I should make this a different color, and I just threw my pen on the floor. Okay. So just organization-wise, I'm going to put both of these kind of in tables so we can kind of see what's going on, right? X is going to be the number of devices, and Y is going to be the total cost per month, right? So Movies for You charges $10 for the first device and then $2 for each additional device. So for one device, you're paying $10, right? For two devices, you add 2, right? You get to 12, 3, 14, 4, 16, 5, 18. Let me make sure my math is correct. Yeah, going up by 2 each time. Okay. So we've got that right here. Now we want to talk about the concept of what makes something a linear function. Okay. And one way that we do this when we're looking at a table, anyway, it's probably the easiest way to do it, is you want to compare the difference between your x values, right? And you're adding 1 each time. And then also compare the difference between your y values. And so in this case, we're adding 2 each time. So since we're adding the same number for our y values and we're adding the same number for our x values, we call this a constant rate of change. Every math class I've ever had has wanted to abbreviate this as CROC. That is totally fine, right? When you see that something has a constant rate of change, you know that it is a linear function. If we were to graph this, it would look like that, roughly, right? It would be a straight line, basically, is my point, right? So it is a linear function because it has this constant rate of change, right? As your x value increases by 1, your y value increases by 2, and that is consistent. And so it kind of just steps along the line like that and matches up. So that is a linear function. That's the definition of a linear function, is it has a constant rate of change, okay? Now, if we take a look at this at Family Stream right here, we see that it's $12 flat rate for up to 4, and then an additional fee of $1 per device for 5 or more. So again, I'm just gonna put it in a table, and we're gonna use the same variables. X is the number of devices, Y is the total cost, right? For one device, you're paying 12. For 2 devices, you're still paying 12. For 3 devices, you're still paying 12. For 4, 12, and then it actually starts to change at that point, right? For 5, you're paying 13. For 6, you're paying 14. For 7, you're paying 15, right? It's going up by 1 for those, right? So when we take a look at this, right, let's use gray, whatever. Our x values are going up by 1. That's still consistent, right? But what happens is these don't go up at all until you hit that 5th device. And then they start going up by 1. So we do not have a constant rate of change like we do here. So this is non-linear. Okay? We do not have a constant rate of change. So the graph basically would look like this. It would be $12, and then at a certain point, it would switch and the price would start going up. So that's kind of the difference between these, right? This does not have a constant rate of change. Let me actually write that. I'm just going to say non-CROC, so we can fit it in there. Okay, does not have a constant rate of change. What do the two plans have in common? Well, they both charge, for additional devices, but their price points are different, right? So when is Movies for You a better deal than Family Stream? Well, let's compare it. One device, right? Movies for You is a better deal, but once you hit 2 devices, that's when they have the same price. After that, it actually starts to become a better deal for Family Stream, which is movies for you, meaning like maybe it's a cheaper deal for one person, but family stream, it's a better deal for a family because you can all have your devices. You can have like your phones, your laptops, your smart TVs, whatever. Um, yeah, that's kind of the difference, right? We have a linear equation or linear function. We have a nonlinear function. And that is what we're going to be doing today. We're going to be comparing linear functions that form a line and nonlinear functions that do not form a line when graphed. Okay? An auto assembly factory needs to purchase new welding robots. The factory manager has information on 2 different models of welding robots. The welding rates for each model are shown below. And then how do the welding rates for the 2 robots compare? Well, we have the T1000 right here. And so again, we're going to figure out the difference between each of our Y values and each of our X values. Use a calculator for this one because the math is not as easy, right? We can see that these are going up by 3 and then 2 and 5. So just initially, this does not look like it has a constant rate of change, but let's keep going, right? Then we'll take that 52 and we'll subtract 20.8 to figure out the difference between them. We get to 31.2, okay? And then 72.8 minus 52 gets us to 20.8. Oh, man, see, it doesn't look like it has a constant rate of change. But one thing you got to realize, what am I doing here? 124.8 minus 72.8, 52, is that our X and Y values are changing each time. So when you have a situation like that, you got to double check, right? So how we double check is we take each Y value or each output and we divide by our input. This will give us our slope basically. And 52 divided by 5. And then, we'll just use our calculator to double check this, right? 31.2 divided by 3 gets us to 10.4. 20.8 divided by 2 gets us to 10.4. Oh, look at that. And then 52, hopefully you can see where this is going, gets us 10.4 as well. So what this means is that this has a slope of 10.4. It can do 10.4 tasks, welding tasks per minute, right? Which is faster than I can do it, definitely. So if we put this in an equation, we get to y equals 10.4x. I think the next problem actually is going to be like welding tasks is equal to 10.4 times the number of minutes, right? So kind of the same thing, just w for y and x for t. So yeah, that's our equation. Our slope is right here. Okay, is that 10.4, and that's what we want to see because we want to see how the other one compares to the speed. We're just comparing speeds here to see which one's faster, right? If anyone has ever seen Terminator 2, the T1000 is the liquid metal model of the Terminator that tries to kill John Connor and Arnold Schwarzenegger. Sorry, the T800 in that. John Connor? John Connor. Yeah, I think that's it. Anyway, that's not important to the problem. So then we have this model GNX007. This graph is not awesome. So the work for finding the slope has already been done for you, right? So rise is here, run is here, right? And remember, slope is rise over run. So it's 11.2 over 1, right? So it's 11.2 tasks per minute. So that's our slope. So we can already kind of see that our slope is faster, right? 11.2 versus 10.4. So the GNX007 is faster. Right? It can do 11 tasks per minute instead of 10 tasks per minute. So that's that. Yeah, so when you're comparing rates, you look for the slope and you see which is the bigger number. That's it right there, guys. Now down here, let me scroll again, we have a third welding robot that is represented by 10.8T. So we can see that it's kind of in between the speeds here, right? So we could say the third robot is faster than the T1000. But slower than the GNX007, which is apparently the top of the line model. Right, and so, these are like welding robots in an auto factory, so they're probably like hundreds of thousands of dollars. Because they have to be very powerful, very precise, and very safe. So a lot of engineering goes into these things. Yeah, I don't know. There you go. Yeah. if you ever run a shop or anything, you'll probably have to do something similar to this to compare. You might not have to actually do this, but you need to be able to compare the slopes and understand what it means. You probably won't have to do the math yourself, but you need to be able to understand how it works and like what it means. Yeah. Okay, so we have a square with side length. That was bad typing there. With S is shown. Actually, it's actually not shown. Yeah, anyway, you can imagine that it's a square and is a side length of S. Okay. The table shows the relationship between the side's length and the perimeter as the side length increases, right? So perimeter is equal to 4 times the side length because you're figuring out kind of all the way around. So you just add them together. So you get to 4S, right? Or just take S and multiply by 4. Same thing. So that's your perimeter right here. The graph shows the relationship between the side length and area, right? And area is equal to S squared, right? Your side multiplied by itself. We had a similar problem the other day for this one. And so I'm actually going to just kind of compare. I'm going to put both on the graph here. I know it doesn't. It says area right here, this is perimeter, but I'm just going to say total number. And so we have our side length goes. So as our side length increases, your perimeter increases, right? So when you have a side length at 0, perimeter is 0, right? And so it just goes up by 4 each time. For that, as these go up by 1. Okay? And now I'm going to actually make a very tall, skinny table for the area. Okay, so this is, we're going to say side length versus area. Okay, so when you have a side length of 0, you have an area of 0. When you have a side length of 1, you have an area of 1, because 1 times 1 is 1, or 1 squared, right? And then 2, 4, because 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. So yeah, we can kind of see here that as these go up by 1, our x values, our s values as well, our inputs, these actually change. So we can tell just from the graph that this is non-linear. This relationship is non-linear, whereas this relationship is linear, okay? So what I'm going to do, I'm going to graph the, actually, let me do this. Put this in purple. I'll do the perimeter in purple, and I'll do the area in that gold color, okay? So perimeter in purple, let's see, 0, 0 is right here, okay? And then 1, 4, we go over 1, and then just before 5, and then over 2, a little bit there, right? 3, 12, 4, 16. So we're kind of eyeballing it, but it's not too bad. I've seen worse graphs, definitely.
Hey, everybody, pardon the interruption. For my parrot, if you're available, not if you're available, we're going to be.
Sorry about that. Get back to it. I know you guys are excited about getting back to the math, so let's do it. So that is what your the relationship for your perimeter, right? As your side length increases by 1, your perimeter increases by 4. So we have that over, let's see, up 4 over 1, up 4 over 1, up 4 over 1, right? Because it's rise over run, right? So you have that linear relationship. It is a constant rate of change. So it looks like a line, okay? Now for the area of the square, it's gonna be slightly different. So 0, 0 is gonna be right here, same point. And then over 1, up 1 is gonna be like right here. Over 2, up 4 is gonna be about right there. Over 3, up 9. Over 4, up 16, actually matches again. Over 5, up 25, right there. And then over 6, up to 36, which is right about there. So what we have, right, connect them with the kind of a smooth curve, just like that. We have a parabola, actually. So this is our area, s squared. Oh man, my colors are off. I should have just done Stuck with the same colors. Come on, get it together. You gotta plan this better. All right, so we can see that the perimeter is a linear relationship, and the area is not a linear relationship. It is technically an exponential relationship, but you will not talk about that until next year when you're in Algebra 1. Yeah, that's, I don't know, pretty easy to tell, right? If it forms a line, it's linear. If it doesn't form a line, it's nonlinear, right? We don't really have the vocabulary yet to talk about, differentiate among nonlinear, curves, but you'll get there eventually. Okay, two linear functions are represented below. Compare the properties of the two functions. Well, for this one, we have a slope of 2. We have a y-intercept of -3. For this one, we have a slope of, let's see here, go point to point. We go down 1, right 2, so we have a slope of -1/2. And we have a y-intercept of 7. So yeah, those are kind of the differences here. If I were to graph this one here, we'd start at -3. Again, I don't have it on here, but it would be about right here. And you go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So it would look like that if you were to graph the equation, right? That y equals 2x minus 3. Right there, okay? Shoot, we might as well put this in here. Y equals -1/2 x plus 7. Just so we can distinguish between the two right there, right? We can see that clear differences in between these guys, right? We have a positive slope here. We have a negative slope here. We have a positive y-intercept here. No. Positive y-intercept here and a negative y-intercept here, right? This one is going up as you look from left to right. This one is going down. This one is actually also much steeper, right? If you're thinking about it in terms of walking up a hill, this one will be like harder to get up than this one, right? Yeah, I don't know. That's kind of how you compare lines. You talk about the slope, and you talk about the y-intercept, right? Which one is bigger, which one is smaller, right? This has a greater rate of change. This one doesn't, right? Greater rate of change means it's steeper. Yeah? That's that, guys. I've already actually put this in a notebook, so I'll just show you the notebook. Again, this is my second version of this video because the sound cut out on the first one. So yeah, put it in your notebook. For me, it's on page 36. I titled it Compare Linear and Nonlinear Functions, which I guess is right there. I mean, you don't need to title it on here, but I would like you to title it in the table of contents right there. That's that, guys.